Hey everybody, today we are going to solve another daily LeetCode challenge, problem 1091, shortest path in a binary matrix. So the problem is we are given an n by n square matrix like the one that you can see here, and we are starting from the top left node, and the plan is to reach to the bottom right node, and we want to find the shortest path from this node. And as you can see, the shortest path in this case is here, because the restriction here is that we can never pass the cells that has value 1. And the matrix that we have is binary, so the values are either 0 and 1, and zeros mean that node is passable, and otherwise 1 nodes are, you can consider them as walls that we can never pass them. In order to solve such problems, especially that all the edges, all the steps are equal, so that means when I pass from this node to the next one, so all of them are equal, so here we are just counting the number of steps. So in graphs that the edges are equal, BFS is the best option to find the shortest path from the source to destination. So here we can just simply, for each one, this problem is an 8-directional problem. That means for each cell we have 8 neighbor cells, top right, bottom left, and top right, bottom right, bottom left, and top left. So for each cell, initially in BFS we have an empty queue, and then initially we just put our starting node, and then we are putting the next node from this direction is a queue that we are appending the new nodes to the queue, and then on each iteration we are just popping the first element in the queue and then visiting that. And by that we are making sure that on each iteration we are visiting the closest cells first, and then we are going to the next one. So here, for example, if I start from this node, then the neighbor cells are being visited, and since this portion is not valid, so we ignore them, and then also these two nodes are 1, so these walls are not passable, so the next node, the neighbor node, will be added to the queue. And then the same happens for this one. After visiting this one, the new node is being visited on the next iteration. Same happens, and then until we see our target goal. So we should, the problem says that this problem is an n by n matrix, so it's a square matrix. So let's first of all we store the length of that, so we have the n, and in order to implement the BFS we have a queue, and then initially you just put the starting node 0 and 0, and then in each iteration, while the length of queue is greater than 0, and ij equal, we are first popping the first element from the queue. Queue.pop. The beauty of using Python 3 is that in some languages you have to choose a queue class, but here in Python we can use simply a list and use it as a stack, as queue, and other data types. So that's why I'm just using a normal list here. And then we should check the 8 directional adjacent neighbors. So for di and dj in, so I want to define a list of 8 different directions, so that I don't want to define that on each iteration. And the list is, if you consider the center node as 0 and 0, the top node would be -1 and 0. The right node, if you this is the I and this is the j, so the right node would be 0 and 1, the bottom one would be 1 and 0, and so on. So we have 8 different directions. So for simplicity, if I don't want to write them down myself, I want to define directions initially as an empty list, and then for the I in range, so I want to put -1, 1, so I can put -1, 0, and 1. For dj in, again the same. If di and dj is not equal to 0 and 0, because if we are visiting a center node, we shouldn't consider that again, because we have 3 by 3 9 cases here, but we have 8 directionals as well. So otherwise, directions that depend, the new direction would be di and dj. So instead of having this -1 1 1, I could use -1 and 2, because ranges in Python is not inclusive. -1 and 2, so those two would be the same. So here, for di and dj in directions, I can simply obtain the index of the neighbor node as ai and aj equals I plus di, the direction in I direction, and j plus the direction in the j direction. So first, we should check if the adjacent node is valid. That means it is not a wall and it is not beyond the matrix boundaries. So if ai is less than n and 0, aj and read I and j equals 0 and not visited. So for visited, since here in this problem, we are not checking if there is an existing path. So instead, we want to return the distance for the path. So one way is to, we can define a visited matrix as well as the distance matrix and store the value for each cell separately. So I want to define a distance initially as a 2D matrix that initially we have -1 for all. So this is the distance matrix I want to define. And then initially all of them are -1. And then when you are starting from the source node from here to the top left, so I replace this one with 1. And then as we are visiting the neighbor nodes, so we are just adding a 1 value to the neighbor node. So if we are starting from this node that has a value of 1, and then we are visiting this one, it would be 2. And at the same time, we can use the same matrix to see if the node is already visited in the previous iterations or not, simply by just checking the distance itself. So if the distance is -1, that means that specific cell hasn't been visited from any other sources. So we can still visit that and add it to our priority queue. So here we would have -1 in range n, and in range n. Then we initialize the distance of the 0 and 0 node with 1. So we have the top left distance as 1, and also it is already, that means visited. So here, and the distance of that node equals -1, that means it is not visited. So then, in order to break this while iteration, if the adjacent node is our target, so let's define our target here as well. The target is n-1, n-1. So if ai and aj equals our target, the bottom right corner, simply just return the distance of source plus 1, because it takes another step. Otherwise, update the distance of that. That means we are going to add that adjacent one to the queue. So from other sources, it shouldn't be visited because it is already in the queue. So ai and aj should be this value, and queue that depends ai and aj. And if there is no valid path exists, so we can just simply return -1 here, because it says if there is no path, just return -1. So everything is good except some boundary cases. So here, if the starting node is 1, or if the destination is 1, we can just return -1 initially, because we are sure that there is no valid path exists. So if grid 0, or let's say n could be 1. So if grid 0, 0 equals 1, or grid -1 and -1 equals 1, then return -1 because no path. So here that means no path found. Same here. And also, let's get otherwise, if the n also is 1, we don't have to do the iteration. So if n equals 1, just return 1. That means we are already in the target node that we are going to visit, so we don't have to run the BFS. So that's okay. Let me put the other test case. All good. And the first test case. Okay, so let me submit that to see what happens. Okay, so that was everything for today. I guess it has been already in the past few months as other daily challenge, and has been repeated again. But the simple way was to use BFS for this problem. But again, don't forget to compare your solution with solutions in the discussions. As you can see, many people are suggesting BFS and the runtime of n. And you can also learn from them the different ways that they have been implemented the solution.